This is the Chapter 9 practice test, and we're going to go through it question by question. You'll have an opportunity to ask extra questions if you want to. I'd like to start by just going through all the questions, and if there's one that you really have a curiosity about, go ahead and make a note. When we do this live in class, I'll pause and give people a chance to ask questions, but when you look at it later, make yourself a note about the ones that you need to go back to. Okay, first problem, probability of finding an even number. So remember, anytime we're talking about the probability of any event, doesn't matter what the event is, probability of any event is the possible things that can happen. So there are 8 possible things that can happen on this spinner. And the top is always the things you want to have happen. So in case of finding an even number, there are 1, 2, 3, 4 even numbers. So the probability of finding an even number is 4 out of 8, which simplifies to 1 out of 2. So the probability of even, 1 out of 2. Problem number 2, the probability of getting a 2 or a 3. So the best way to do this is to break it down and do it in parts. What's the probability of getting the 2? Well, there's 1 2 on the spinner. There are 8 things possible, so there's a 1 out of 8 chance that you'll get a 2. And probability of getting a 3, same situation. There's 1 3 out of 8 choices. So the probability of getting a 2 or a 3 is to add those individual probabilities together. Add the probability of getting the 2 to the probability of getting the 3, and we get a 2 out of 8 chance, which simplifies to 1 out of 4. So there's a 1 out of 4 chance of getting a 2 or a 3. Probability of not getting a 4. So the key here is the word not. If you think about the probability of getting a 4, if you take a 4, well, the probability of getting that 4 is 1 out of 8. There's 1 4 on the spinner out of 8 possible. So the not probability, this not, is the complement of that. Remember, the complement is all the other things that can happen. So if there's a 1 out of 8 chance of getting the 4, then the probability of not getting the 4 are the other 7 out of 8 things that can happen. And if you go back to your spinner, yes, there's 1 4 right there, but there are 7 other things the spinner could land on. So the probability of not getting a 4 is 7 out of 8. All right, problems 4 and 5 go with this idea of getting what we call sample spaces or fundamental counting principles. Probability of picking a month of the year and tossing a coin. So what you want to ask yourself is, how many of each are there? Well, for months, there are 12. On the coin, there are 2 things that can happen, heads or tails. So let's go ahead and actually build this out. Let's see what this would look like. All right, boom, a sample space appears for problem 4. So this is the sample space. So when we do our sample space, we're going to start with the months. So for the months, we've got January, February, March, April, May, June, this was January. Let's just do those first 6. So altogether there would be 12. Let me list the others. I'm not going to fill them all in, but here we'd have July, August, September, October, November, and December. So we've got our 12 months of the year. For each of these months, we could pick January and then flip heads, or pick January, flip tails. February, flip heads, or February, flip tails. March, flip heads, or March, flip tails. And we can continue that for all the rest of these. For each of these, we have that same situation. Flip heads or tails, flip heads or tails, flip heads or tails. Every single time, flip heads or tails. The idea is there are 12 different months, and each of those months has 2 different coins. So when we're looking at how many different things can happen, 12 months, each of those months has 2 different coin possibilities. There are 24. How do we figure that out? The 12 possibilities in the months times the 2 possibilities of the coins give us 24 things that can happen. Same when we get down to number 5. Outcome, pick the number 1 through 10 and days of the week. So we know there are 10 digits. Number 1 through 10 have 10 digits. The days of the week, there are 7 days of the week. So there are 70 possible outcomes that could happen. You could have the number 1 with Saturday, 1 with Sunday, 1 with Monday, 1 with Tuesday, 1 with Wednesday. Get through those first 1 with 7 different things, then 2 with 7 different things, 3 with 7 different things. So our shortcut, we could build another sample space like we did on the last one, but our shortcut is to say there are 10 digits, there are 7 days of the week. This is days of week right here. This is 10 because we had 10 digits. We said we're going 1 through 10, so 70 possible outcomes. All right. Bags of beads. So the question is, you select a bead, you keep it. You select another bead. What are the probabilities? Here's the thing to underline. Here's the thing to remember. You kept the bead. So after you pulled that first bead out, you held on to it. You didn't put it back into the bag of beads, which means when you pulled that first blue bead, there were 5 blue beads. So there were 5 blue. There were 10 total. When you got ready to pull that first bead, there were 5 blue. There were a total of 10. 5 blue, 5 yellow. So the probability of that first blue was 5 out of 10. This is the first blue. Had a probability of 5 out of 10. When you got to the second blue, well, there's a blue bead gone now, right? There are only 4 blue beads left. You pulled one out and you kept it. So there are 4 blue beads left, and there are only 9 beads total because you pulled a blue bead out and you kept it. So our shortcut is to say we have a 5 out of 10 chance of the first bead. We have a 4 out of 9 chance of the second bead. I'm going to bet that some of you back here, some of you simplified this, which you should have done. I'm going to simplify it right here. It's going to make my multiplication easier. A 1 out of 2 chance. I always like cross-canceling. 2 goes into 2 once. 2 goes into 4 twice. 1 times 2 is 2. 1 times 9 is 9. And that's the probability. The probability of blue keep then another blue is 2 of 9. All right, number 7. So in problem number 7, Bailey tossed a coin 10 times, and here were the results. He got heads 3 times, he got tails 7 times. Our first question, what is the experimental probability of tossing the tails? Remember, experimental is what actually happened. You did the experiment, in this case tossing the coin 10 times, and what actually happens, or happened, let's make that happen, that is the experimental probability. So experimental probability of tails in this case, well, there were 7 tails out of 10 tosses, so the experimental probability was 7 out of 10. Number 8 also works with this information, so let's keep this in mind. And in number 8, we're asked, what's the best comparison between the theoretical and experimental probability of tossing heads? So this time we're tossing heads, not tails. So if we look back at the information on the previous problem, for heads this time, we got heads 3 out of 10 times. So theoretically, we would expect to get heads 5 out of 10 times. That is the probability of tossing heads 5 out of 10. But when they ran the experiment, they only got 3 out of 10. So we're comparing theoretical to experimental. So 5 out of 10 compared to 3 out of 10. Well, the theoretical is greater than, boom, the 5 out of 10 is greater than the 3 out of 10. Our correct answer is A. Number 9, we have marbles. So we have a jar with 5 blue, 6 yellow, and 4 green. What's the probability of randomly choosing a yellow? So you're going to pull a yellow. You are not going to replace it. That's important to keep in mind. And then you're going to pull a blue. Well, the chance of pulling the yellow, the probability of getting that yellow marble, there are 6 yellow out of 5, and 6 make 11, and 4 make 15 total. So there is a 6 out of 15 chance that you're going to get a yellow marble, which we can simplify to a 2 out of 5 chance. Now the probability of getting the blue marble, well, there are 5 blue marbles. There are only 14 marbles left because we pulled the yellow marble and we did not replace it. So there are only 14 marbles left, and 5 out of 14 cannot be simplified. So here we have a 2 out of 5 chance of getting the yellow times a 5 out of 14 chance of getting the blue. That's what we do with dependent events. This has some simplifying we can do. 5 goes into 5s like so. 2 goes into 2 once. 2 goes into 14 7 times. 1 times 1 is 1. 1 times 7 is 7. Our correct answer is C. There is a 1 in 7 chance that you're going to pull a blue and then turn around, pull a yellow and then turn around and pull a blue. All right, so we have a 6, probability of spinning a 6, then spinning a 6. So we have 1 6 out of 7 spots on the wheel, which means the probability of spinning a 6, there is a 1 out of 7 chance. Now, unlike the marble jar, we don't take anything out and keep it. So the 6 is still there. So the next time we spin, the probability of a 6 is still 1 out of 7. So we have a 1 out of 7 chance of the first 6 and a 1 out of 7 chance of the second 6. We have a 1 out of 49 chance of getting 2 6s. Number 11. Employees at a company are given 3-digit employee identification codes. If each digit is not repeated, these are the things to remember, If each digit cannot be repeated, how many different possibilities are there? Well, this falls into the idea of permutations. And if you looked back at 766 in example 2, you'd see that what they're asking us to do is they're asking us to take 10 items. There are 10 digits, 0 through 9, and figure out what a group of 3 would look like. How many different ways could you have a unique group of 3 out of 10 digits? And it has to be unique, right? Employee code 123 is different than employee code 321. So the way that we solve that is we take the 10 possibilities. You pulled one digit out. Now there would be 9 ways you could organize it. Pull one more digit out. Now there are 8 ways you can organize it. This is this 3, right? The 10 digits tell us how many different things there are possible. The 3 tells us how many of those things we're looking at. And so we would multiply these together. 10 times 9 is 90. So we'd have 10 times 9 is 90, times 8 more is 720. There are 720 different code possibilities for those employee IDs. Same idea on number 12. Coach Frazier is going to select a captain and a co-captain. There are 22 students. She needs to select 2. How many different outcomes are there? Well, each student could be captain, or each student could be co-captain. So this is a permutation where you have 22 different possibilities, and you're pulling out groups of 2. So you're doing 22 possibilities for the first person. Let's say they pick Maria as person number 1. Maria can't be person number 2 now, so now there are only 21 people left, and any one of those 21 people could be the co-captain. Or it could be that Luis is the captain. Now there are 21 left, and Maria is the co-captain. So those are 2 different things. Maria and Luis, captain, co-captain, would be different than Luis and Maria, captain, co-captain. So we'd have 22 times 21. 22, 21, 2, 2. 2 times 2 is 4. 2 times 2 is 4. We would have 462 different possibilities. Number 13, you toss a coin 3 times, complete the list of the 8 outcomes. So I always like to complete my lists in an orderly fashion. So if it's going to start with heads, 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 it's going to end with tails, tails, tails. So this will be the one that has 2 heads and then a tail. And this will have a head, a tail, and a head. And this will have a tail, a head, and a tail. Oops. Nope, that last one will not be a tail. That last one will be a head. So now I've done all the things that can have 2 heads. 2 heads, then a tail. 2 heads with the tail in the middle, a tail, then the 2 heads. Then I shift to the tails. So this will have 2 tails and a head, a tail, a head, and a tail. And the head, the tail, the tail. So this is all heads, all tails, all the things with 2 heads, all the things with 2 tails. What's the probability of getting 2 or more tails? That's the nice thing about organizing my list this way. Here are all the things that get you 2 or more tails. So you get 2 or more tails with half the list. There are 8 possible outcomes. So the probability of, do this in math talk, the probability of greater than or equal to 2 tails is 4 out of 8 which is 1 out of 2. There's a 1 out of 2 chance. Okay, if you're watching this as a review at home, go back, look over any of the problems, go back to the pages that are given for the explanations and the examples. Come in ready to be successful on the test.